My best wishes to all the viewers. Welcome to DT Studio. DT Studio is organized by the Director of Technical Education in Karnataka, Bengaluru. Now I am teaching the subject Surveying 2 prescribed by the Board of Technical Examinations, Board of Technical Education. Now this is the 18th class. Now I am discussing about the curve surveying. Curves. This is the third class. Now I will give the fundamentals of curves which are employed in construction of roads, introducing in between in the roads and railways. Now we are discussing about it. There, in the curves chapter, till now we have discussed the fundamentals. Now today also I will discuss few slides about the fundamentals. Then I will discussing about the linear methods of laying the curves, linear methods of ranging the curves, curve ranging. Now we'll discuss. Let us see one by one. We'll go ahead and we'll continue with this. Now already we have discussed about the surveying many topics, and again I'm recalling the trigonometrical functions. Without trigonometrical functions, we can't do anything. We can't deal any kind of technical work. Isn't that? That too related to that curve surveying and analysis, and also resolution of forces. Like we need the fundamentals. This is the basics. Engineering basic. We should know about it. Then we elaborately have discussed in the previous classes, the curves are classified into two, that is horizontal curves and vertical curves. Horizontal curves are the curves in the horizontal plane, and vertical curves are in the vertical plane. The horizontal curves are further classified into, that is a simple curve, compound curve, then reverse curve or S curve, and also transition curve. And the vertical curves are, that is summit curves and valley curves. We have the curves are classified. Now it is summarized. I am summarizing this in the previous class what we have discussed about it. Now here, this is the simple curve consisting of the arc of the circle. So from beginning to the end, the radius is same. That is the part of the circle is taken as the curve, and it is introduced between the two straights. Simple curve consisting of arc of the circle. Now here the compound curve is another. It is consisting of two simple curves. Now here the radius of this curve and this curve are different. Now sometimes this curve radius is less and this curve radius is more when compared to this. Or sometimes maybe vice versa also. This may be more and this may be less. Now that depends upon the engineer who has to decide which he wants to incorporate in designing the roads and railways. And the reverse curve is another curve. Now it consisting of two simple curves. Now whereas here the direction of the curve, now here the centers, radius of the first curve, radius of the second curve. The radius of the first curve and the second curve the centers of the first curve, it is O1 and O2 are on the opposite side. Whereas in the compound curve, the centers are on the same side. The centers of the first curve, centers of the second curve are on the same side. Now, whereas in the reverse curve, the centers of the first curve and centers of the second curve are on the opposite sides. And also similarly, a transition curve. A transition curve is the curve which is introduced between the curve and the straight. Isn't it? That is to make the vehicle smooth movement. Now that means a transition curve is the curve 1 which has different radius. Isn't it? Now here the transition curve. This is the part of the transition curve. Now here the radius at this point, the radius is equal to radius of the transition curve is equal to the radius of this curve, isn't it? Now, if you go to the next point, the radius of the transition curve is more than this r, and similarly, if you move, the radius of the curve is little more than that, and at the end, it is joining with the straight line. Then the radius at that point is infinity. Now, these are the types of curves employed, different kinds of curves employed in our regular practice. And the vertical curves. The another classification is vertical curves. Now, these are the vertical curves that is lying in the vertical plane. That means upward, downward, downward, upward. Now, there are different classifications, different types of curves, that is vertical curves, are employed. Now, this is downward followed by downward, that is downward followed by horizontal. Now, here downward followed by upward, here upward followed by upward, like Now, there are different types depending upon the circumstances of the designer and the topography of the area where you need to compromise with the money or the construction cost of the road or railway line. You have to decide which is the best curve to be employed for different construction of roads. And similarly, now we have elaborately discussed about this. Now, these are the terms used in curve survey. These are the fundamental terms one should know about. If you know, these are the standard abbreviations used in laying the curve, in understanding the curve, isn't it? Well, if you know this, now we very easily we can handle the curve. Now, these are the terms. When you go to the field, then the people will speak about only the point of curve, point of intersection, straight, tangent, like central angle, deflection angle. We must be able to understand, isn't it? So therefore, please note this. The continuation of this again. This is the external distance, and this is the length of the curve. Length of the curve is the length of the curve. This is the curve, isn't it? Now, this is a long curve. This is the radius, and this is the straight B dash, and B C is another straight, isn't it? The T1, T2 are the tangent points. That is the tangent point, length of the tangent from T1 to B, and B to T1, T2 are the tangent length of the tangent. Now, please remember, now this is the long chord and this is the length of the curve. And similarly, now we have all the abbreviations of terms used, which are terminologies used in curves, are mentioned here, in the diagrammatically shown here. If you go through this, definitely one can understand the terms of each element, isn't it? Each element of the curve we are dealing in the construction of the road and railways. Now, therefore, whatever may be the case, but being the engineer, you have to decide which is the best curve where you have to fit and which type of road, and mainly that depends upon the speed of the vehicle, isn't it? The type of the road, that is village road, district road, taluk road, etc. That you have to decide. It is decided by the engineer which curve is more suitable, isn't it? Now, there are no ready data are available with the MOST, Ministry of Surface and Transport. No ready data is available. Now, depending upon the type of the road and depending upon the topography and the width of the road, speed of the vehicle, based on those factors, ready curves are available. The ready data, the number of types of curves of data available with the MOST, that is Ministry of Surface and Highways, National Highways. We will get all the data. Straight away we can apply it. Sometimes we may need to modify it depending upon the local circumstances, depending upon the topography of the area where we are constructing the road. Please remember this. And another the elements of the curve, how to calculate those elements. Now, that is another important issue to be addressed by the engineers. Basics, these are the fundamentals and basics one should know about it. That is, please note, this is the deflection angle, this is the intersection angle. Sum of the intersection angle and the deflection angle is equal to 180 degree. Sum of the deflection angle and intersection angle, isn't it? And we know how to calculate the tangent length. To calculate the tangent length, please resolve or analyze this triangle, that is V T1, that is O, V T1 O. If you resolve, if you analyze the triangle, now we are able to calculate now this is not now tangent length. Now because deflection angle is decided by the engineer, he knows it, and radius is decided by the engineer, isn't it? So therefore, now this is which curve is to be employed and what is the deflection angle. Once we know this, now definitely it is possible we can resolve this triangle, we can analyze this triangle, that is BT1O, and we can calculate the tangent length, isn't it? Similarly, we can calculate that there is no tangent length and tangent length. This is the forward tangent and this is the rear tangent. We can address this. We can solve. And similarly, now here, now the length of the card length. Now this is the length of the card. Now analyze this triangle. Now this is T1E O. Analyze this triangle. R is known, delta is known, delta by 2. This is half of the central angle. Delta by 2 is known. If you analyze this triangle, now definitely we can solve. We can find out the tangent length. Is sorry, card length. Card length can be calculated very easily. And similarly, now that is the curve length. Now this is the length of the curve. Now how to calculate the curve length? Isn't it? Now this is the length of the curve. This it can be calculated is equal to L is equal to R into theta. R is the radius of the curve and theta is the angle subtended by the curve. That is the angle subtended by the curve. This is the delta, isn't it? R into delta. R is the radius and delta. R is now from this we can calculate it R into delta. Now we convert this. Now the radians. Now we will get that is the length of the card length. Sorry, curve length can be calculated. Now one should know about it. Now how to calculate the length, curve length, how to calculate the card length, and how to calculate the tangent length. Like no one should know about it. Doesn't matter. If you know these fundamentals, we can address or we can address any kind of curve. Any kind of curves can be solved. Now with the trigonometrical functions, basic trigonometrical functions, it is possible we can address it. We can calculate it. Okay. And similarly, now this is one Wurster sign EF. Now this is called Wurster sign. This is R. R. If you take out the R outside, 1 minus R, 1 minus cos delta by 2. Unit 1 is unit minus cos theta is called Wurster sign. Isn't it? Now we can call this as Wurster sign. Now this is the distance between E and F. Isn't it? This is called Wurster sign of the curve. And similarly, now the ranging methods. There are different types of methods we are employing. We are employing in ranging the curves. Now again, depending upon the equipments available, the time available, type of the road, isn't it? And the urgency. Now based on these factors, now you have to decide which is the best method to employ to range the curve. The ranging the curve means now we have worked out. First you go to the field, calculate the data, then process it, isn't it? Then calculate all the data, then again transfer the curve to the field, isn't it? From paper to the field. First we'll collect the raw data and process it in the computer and calculate the length and calculate everything, then again transfer the curve to the field. Now this is called ranging, curve ranging. From paper, transferring the curve from paper to the field is called curve ranging, isn't it? Now there are many ways. One is linear method. That linear method means only applying the chain and tape, isn't it? Chain tape, of course, other accessories may also be required. Now that is like pegs and cross stop, etc. may be required in the linear methods. The mainly we are employing the chain and tape method. Now this is called chain and tape method. Now here, we will explain one by one all these things. And similarly, that is another method is called angular method. Angular method means it is a tangential angle method. It is by employing the theorite, that is by measuring the angles, isn't it? Now therefore, what are the data to be calculated? Now which curve will be transferred from paper to the field by which method? Now we will discuss one by one, isn't it? Now we will discuss one by one. Let us see. Now here, now before doing that, now one should understand this carefully. Now here see, that is one unit card and sub card. Now card is, this is the long card. We are calling this as long card. And if you divide this, now in number of cards can be drawn. From here to here, if you draw a line, now this is another card. Now number of cards can be drawn to this curve, isn't it? Now if you draw one line like this, now this is another card. If you draw another line from here to here, this is another card, isn't it? Now this is one card. From here to here, it is one card, and this is one card, and this is another card. Like there are number of cards, isn't it? Card is a line drawn to both on the curve, isn't it? It is connecting. See, from the here to here. Now this is the card, isn't it? In many cases, the card length and the curve length are approximately nearly equal, isn't it? Not exactly equal. The card length and the curve length are nearly equal, isn't it? Right? Therefore, no, it is not possible to draw the curve directly on the field, on the ground. Therefore, we are employing the very different methods. Now, here one thing you should understand. Now, how to divide this. Now, there is a systematic approach. There is a systematic way, isn't it? There is a disciplined way, because we are all engineers. We will let us adopt one disciplined way. Now, therefore, now how to divide this curve? Now divide the curve. First calculate the length of the curve length by applying this R into the delta. R into delta, we can calculate the length, isn't it? R is known, delta is also known. R is the radius of the curve, which is used in the designing the curve, and delta is the deflection angle. These two are known. Therefore, we are able to calculate the length of the curve. Curve length can be calculated, isn't it? Once you calculate the curve length, then divide this curve into cards, isn't it? Number of cards. Now again, that if you make more number of cards, the curve is, you will get the exact curve shape, isn't it? If you have less number of cards, then curve shape may be some error in that. Therefore, but anyhow, the engineer, you have to decide which is the best card depending upon the length of that is time available, then length of the total length of the curve, like you have to decide. Okay. Now, therefore, normally what we will do, the card length, now this is one card length is normally we are applying one chain length. One chain length is the card length, isn't it? Now, therefore, now we will see how to get it. Yes. See, I have taken one example here. One example for unit card and sub card. Now, please you can understand this here. Chain edge of B is assumed as 2550 meters. And length of the curve is 455 meters. It is calculated, isn't R into delta. Isn't it? By considering R into delta, we have calculated the length, isn't it? Curve length. After calculating the curve length, isn't it? We will get, let us assume that it is 455 meters. Isn't it? Then calculate the tangent length. It is assumed that the length of the tangent is 175 meters. From here to here, it is 175 meters. Isn't it? Considering the unit card, one chain length means approximately it is 30 meters. Isn't it? One chain length, it is 30 meters. It is 30 meter chain length. Isn't it? 30 meter chain length. Not necessarily it is 30 meters. That depends again. The type of the curve, isn't it? Maybe it is 20 meter you can take, or 10 meter you can take, whatever way in which you want, you can take it, isn't it? No. That is one chain length, 30 meter I have taken here. Therefore, number of cards. See, now it is 455 meters, it is 15 cards. 15 cards plus one sub card will go to get it. That is, unit card means each length of each card is 30 meters, and at the end we are going to get one 5 meter sub card. Understood? Got it? Isn't it? Now, therefore, now please understand that is the curve is divided into 15 unit cards plus one sub card. There are total number of 16 cards. Isn't it? Now, please note again. Now, here the last card, one sub card. That is last card. What is the length of the last card? After deducting 450 meters, what is the remaining? Remaining is 5 meters of card, isn't it? 5 meters of card we will to get it. When compared to this 30-meter unit card, that 5 meter is less. Therefore, what I will do now? Now I will take it. I will make it as 14 unit cards and 1 sub card. Now the 14 unit cards, 14 multiplied by 30 meter, isn't it? Plus 1 sub card. What is the length of the sub card now? Length of the sub card is now how much? Length of the sub card is 35 meters, isn't it? Right? There are 16 cards, 15 multiplied by 30, 450 meter plus 5 meter. 5 meter will be the sub card, isn't it? 5 meter will be the sub card. Now what I will do, that 5 meter is very small for our calculation purpose. Data will getting very small data. Therefore, now we will make it like this. I will make this, that is, instead of making 16 total cards, 15 unit cards and 1 sub card, I will make it 14 unit cards and 1 sub card. 14 unit cards length is 30 meter and 1 sub card unit. Sub card length is 35 meter, isn't it? Then how many cards we have now? 15 cards, isn't it? Now this just I have shown this as an example. Okay, and also another important thing we should know about here is, now we must calculate the chainage of this point T1, isn't it? What is the chainage of? Now it is assumed that we are traveling from here. And we have reached and we have traveled up to here. We reached this point. Therefore, the chainage of this point is 2,550 meters. Chainage of this point. Please note, isn't it? There will be a confusion with our students. Please note. Now here, now we are traveling from here. We don't know from where we are traveling. No, it means that from 0 we have started far away at a distance that is 2,550 meters. Now and we reached. Now this is the point where the point of intersection. The chainage of the point of intersection is how much? 2,550 meters, isn't it? Now what we should do now? Calculate the length of the tangent. Calculate the length of the tangent. Isn't it? Calculate the length of the tangent, then deduct this length, tangent length, from this, isn't it? From the chainage of B, deduct what? Length of the tangent length. Deduct the tangent length. What we are going to get it now? Chainage of T1 we are going to get it. Got it? Understood? T, we are traveling from somewhere here. We have traveled. Now we are measuring the distance. And we have reached. This is the point of intersection where we need to change the direction of the path. Isn't it? There you have to change the path. Isn't it? Therefore, we are now introducing the curve between these two straights. Isn't it? This is 2,550 meters we have reached. Chainage of the intersection point is so much. Then calculate the length of this tangent and deduct the tangent length. Then we will get the chainage of T1, isn't it? Got it? Chainage of T1 we are going to get it. Then plus add the card length. Now this is the chainage of T1 is how much? 2375. 2375 meters is the chainage of T1. Then what is the chainage of this point now? 2375 T1 chainage plus card length 30. Okay. Then what is the chainage of this point? Plus 30 plus 30. Likewise, continue, and what we are going to get it at the end. At the end, we are going to get the chainage of T2. Okay, understood? Now these are the procedures we should follow. before handling the curves, these are the data to be calculated, isn't it? These are the data to be known, isn't it? Sometimes many in the preliminary data we are collecting the data from the site and from the field, then we are processing it, and all these things should be prepared in the office, isn't it? First you do this job, first understand all these things, then now we'll see what next. Now see, now this is locating the tangent point. What I have explained now, the same thing, isn't it? I have explained here. Now what in the previous two slides we have explained, now it is summarized here, isn't it? First calculate the tangent length, calculate the curve length, isn't it? Now sometimes these are the things will be asked in the examination. Each slide may be a question in the examination. Therefore, yeah, for 5-mark question, sometimes 7-mark question, sometimes 8, like that depends upon the examiner. Now see, tangent length, calculate the tangent length, calculate the curve length, isn't it? Then knowing the chainage of B, deduct the tangent length and get the tangent length chainage of T1. Then add the curve length, we'll get the chainage of T2. It is a simple process. Understood? Got it? Okay, we'll go ahead next. Okay. Now we'll come to that is offset from that is ordinates from the long card. Now for the given curve, now I think we understood all the terminologies. This is all these things. This is the length, curve length, and this is the curve length, long card, tangent 1 and tangent 2, radius, and the central angle. No, is none. Right? Now this is the linear method of arranging the curve. Now how to calculate it? What are the data to be calculated, and which data to be transferred to the field? Isn't it? So this is we will let us learn now carefully. Now please understand this again. Now see, tangent, isn't it? First straight, second straight, tangent length, then tangent length, isn't it? Now here, this is that is central distance, isn't it? From O to B, not middle of the curve, half of the curve. And now let us calculate. See, length of the card, then O in the mid ordinate. Now already it is called versus sign, mid ordinate. We can calculate how to calculate this ordinate. These are the ordinates. First ordinate, second ordinate, third ordinate, fourth ordinate. Any number of ordinates can be, isn't it? We can calculate it. Now depending upon the way in which you want to lay the curve. Now therefore, please, there is some concession here. Please understand. Now let us calculate this ordinate. What is the ordinate? How to calculate the ordinate at distance x from the center, isn't it? Center of the long card. How to calculate this x? Now the ordinate. What is the ordinate? How to calculate the ordinate? This ordinate. Now therefore, from triangle OT1E. Now from this triangle, now see this length from here to here. What is this? The total length of this is long card L, and T1E is what? L by 2, half of the long card. This is half of the long card. OT1. So this is Pythagoras theorem. Apply the Pythagoras theorem and calculate. See, isn't it? It is a simple method. Just solve this triangle. We'll get all the data, isn't it? Now therefore, now here, that is considering this triangle OT1E. Now here, this is the hypotenuse, isn't it? This is the hypotenuse. That is OT1 square is equal to T1E square plus OE square. Is it right? Pythagoras theorem. Now we know this. This is R. And we know this. This is L by 2. And what is this? This is how much now? OE is. Now from O to D, what is this O to D? What is this? O to D is what? Radius of the curve, isn't it? This is radius, no? This is radius. Now from here to here it is again radius. Now from here to here it is again radius, isn't it? Now therefore from here to here it is radius. Now from here to here what is this distance? Mid-ordinate. Already we have calculated. It is versus sign, isn't it? It is versus sign. Now this is, we know that. Now therefore, now this OE is equal to R minus OO. R minus OO, isn't it? See, now we are analyzing this triangle. OT1E. We are analyzing OT1E. OT1E triangle we are analyzing. Now we know this is R, OT1, Pythagoras theorem. This is the Pythagoras theorem for the triangle OT1E. Now here OT1 is equal to R now. Then T1 is equal to L by 2, isn't it? Then OE1 is equal to R minus OO, R minus OO. Now substitute this value to the, isn't it, Pythagoras theorem. If you substitute this, we will get OO is equal to, and simplify this. If you, after simplifying this, we are going to get this, isn't it? Now R is known, L by 2 is known, substitute the value, then we will get the ordinates, isn't it? Now mid-ordinate we are going to get it. Mid-ordinate. Similarly, see, now this is mid-ordinate is once done, finished, we have completed, we have calculated, and now we have to calculate the ordinate, another ordinate at a distance x from E to, isn't it? This is one point. Here, at any point we can calculate the distance, isn't it? At any point we can calculate the ordinate. This is the first ordinate, this is the second ordinate, this is the third ordinate. Any number of ordinates can be calculated, isn't it? Now therefore, now let us handle this triangle. First we will calculate this OX. Now this is OO, that is mid-ordinate is OO. Now this is OX. Now this ordinate is OX. Isn't it? We don't know what is that. Now we have to calculate that. Isn't it? OX is the ordinate at a distance x from E. Got it? Understood? Okay. Now consider this triangle, that is OQQ1. Consider this triangle. Now this triangle. Now from here to here, now consider this triangle. It is OQQ1. Now again, from here to here it is R. From here to here it is R. And from here to here it is OX. And from here to here it is X. Isn't that? Got it? Understood? Now let us apply the Pythagoras theorem again. Isn't that? That is, now this is the hypotenuse. This is a OQ is hypotenuse. Now here OQ square is equal to, that is QQ1 square plus OQ1 square. Isn't that? Now this is what we have written here. Pythagoras theorem. Now we are addressing, or we are analyzing this curve OQQ1. We are addressing this curve, isn't it? Sorry, this triangle. Now solve this triangle. Now we will get. Now see, now this is the Pythagoras equation we applied. Now here, now just now we know this. Now from here to here it is R. It is from here to here OQ. OQ is R. Then QQ1 is X. QQ1 is X. Isn't that? Now substitute this. Now we are going to get OX is equal to that is X is equal to, now this is the equation we are going to get it. Isn't that? Just by solving this triangle, just solve this triangle, we will get this. Isn't that? Okay? Understood? Now similarly, now then OX, now this is the equation we are going to get it. And similarly, we have another equation. No, this is strictly speaking, it is the exact equation to calculate the ordinates. OX is the ordinate from the long chord at a distance x from the center. Isn't it? X from the center of the long chord. Now, this is the exact equation. And this is another equation. This is approximate equation. Now, here the x is considered from the descent. X is considered from the descent. Now, from here we are considering this is x. Isn't it? X is the distance. Now, L we know that is L is long chord and x is the distance at which we need to calculate the ordinate. Isn't it? X is the distance from which, now here in this case x is considered from E, whereas in this approximate case x is considered from this side. Okay. Now just solving the triangle, applying the Pythagoras equation, now we can solve, we can find out the data required to set the curve. And similarly, yeah, this is one example. This is one example, that is applying the same, that is equation what we have done. Now we have discussed, that is laying how to lay the curve, that is arrange the curve of simple curve by chain and tape method, that is by long chord, offset from the long chord. Now it is given, calculate the ordinates at 7.5 meter interval for a circular curve, given that the length of the chord is 60 meter and radius is 180 meter. Now this is the data given. R is given, radius of the curve is given, then long chord is given 60 meter, and they have asked to calculate now here at a distance of x. X is 7.5 meter. Isn't it? They have asked to calculate the ordinates and set out the curve. How to get set out the curve? So therefore, they employ those equations, formulas what we have discussed in the previous slide. Employ the O1, that is the mid ordinate. OO. OO is the mid ordinate. Now we know this. R is known, L is known. Substitute this, we will get that is 2.52 meter. The mid ordinate, this is the 2.5 meter. 2.52 meter. Isn't it? And similarly, apply the next equation, that is now here, that is the exact. Now we apply this equation and substitute the value. R is known, X is known. Now what happens here? Now this is, now considering this is ordinate, from here to here it is 7.5 meter. Next ordinate is at a distance of 15 meter. Next ordinate 22.5 meter. Now we have done it, now here it is 22.5. Isn't it? That is 0, 7.5, 15 meter, 22.5 and 30 meter. Isn't it? Calculate the offsets. Isn't it? These are the offsets or ordinates. Ordinate from the long chord. Ordinate from the long chord. Calculate this, and similarly, now another approximate method. Now this is the equation. Employ this equation that we have discussed in the previous slide. Now this is from here. It is 0.75. Now substitute. See x. It is 7.5 meter from the T1. From T1, 7.5 meter. Then 60 meter is the length of total length. That is the long chord. Then minus x 7.5 divided by 2r. It is 2r means radius. 2 into 180. We will get. Now this is the at a distance from here to here. Isn't it? That is ordinate. Second ordinate at a distance 15 meter. We are going to get 1.875 meter. And third ordinate we will get, that is 2.34 meter. And the fourth ordinate, that is O30. Now from here to here 30. Now it is 2.5 meter. Isn't it? This is the calculation part is done. Then next, now we will prepare the table. Now this table is called curve table. We are calling this as, we will call this as curve table. Isn't it? You have to carry this, you must carry this data to the field. You must go with this data with the field, to the field data, this data, curve table, chain, tape, arrows, and crosstalk. Isn't it? You have to carry these things, go to the field. Then how to do this? Isn't it? Now Now from first you go through this. Now see, it is the distance. It is the distance from here, 0, 0 to, isn't it? From 0, it is first ordinate. It is OO. Already we have calculated this 2.5 meter. This is alpha at first ordinate at 7.5 meter distance, 2.36. Second ordinate, it is 15 meter, isn't it? 15 meter to 1.89 meter, and third ordinate, it is 1.1 meter. At the last point, that is here, the ordinate is equal to 0, isn't it? This is exact method. In the approximate method, we can calculate. Now this is from this end. The first one is 0. The second one is, this distance is 1.09. Then approximately you can check this. Now we have calculated in the exact method from this end. In the approximate method, we are calculating this from this end, isn't it? Now from here to here. Okay, got it? Now we'll see with this data how to transfer this curve. No, just I will explain this on the board, isn't it? You just look at, you just follow. That is the method how we will proceed with this, isn't it? Now first, I will take the data. Take this data. Data means curve table, you know. Take the curve table data. Then carry the chain, tape, then cross tab and arrows. Okay, understood? Will you follow this now? Shall I write down? Okay, now first, that is the intersection point. This is the intersection point. This is the intersection. Now where we need to. Then tangent, that is tangent line. Calculate this tangent where you need to start the curve. Now this is the long curve. You draw this long curve. First you draw the long curve. That is 60 meter is given in this. You mark this 60 meter long curve. 60 meter. Then divide this half. That is 30 meter and 30 meter. Pull the chain from 0 to 60 meter, isn't it? Pull the chain. This is long curve. Long curve. Go to the field. Go to the field. Carry the table. That is curve table. Along with the curve table, chain and tape, cross off. Pull the chain for 60 meter. Where you will commence the curve point of curve from the beginning. Then divide this long curve and fix the cross tab and 2 ranging rods on either end. 2 ranging rods on either end, and fix the cross tab and move the tape take with the tape, with the help of tape. That is OO. I think it is 2.5 meter. You cut it. This is the OO. This is OO. That is the mid ordinate. Then next, move this cross tab to the next location. It is 7.5 meter. It is 7.5 meter. Fix the cross tab and bisect this ranging rods. Then again it is 2.35 meter. I think it is 2.35 meter. This is OX1, first ordinate. Then again from here to here it is another 7.5 meter. It is from here to here it is 15 meter. Then again see, fix the cross tab and bisect the ranging rods. Then along this line cut it to the third angle. Isn't it? This is the third ordinate. And similarly, now see again. Similarly, for the next, that is another 7.5 meter. Now this is 7.5 meter. then bring the crosstalk, fix the crosstalk, then again, that is for the last offset, cut it. Isn't it? Now in the field we will get 1, 2, 3 and 4 points. Similarly, do it to the other side also. Continue this to the other side also. Then smoothly join this, we will give them the required curve. Now this is the curve, required curve. Isn't it? And continue this. Now that will give us the likewise. Now we have transferred the curve to the field. Now isn't it? Now this is the simple method. This is simple method. That is linear method of locating the transfer the curve from paper to the field. Got it understood? Yes. Okay. Then see, like I see the same thing is explained here also. I have mentioned this. First, pull the chain 60 meter. Then mark the center of the long cord. Mark the center of the long cord. Then fix the crosstalk here. Then erect the perpendicular. Cut it to the OO, ordinate, first ordinate. It is OO, it is 2.5 meter. With the tape, cut it. Then 7.5 meter, the first ordinate, OX1. Now this is 7.5 meter from here to here. It is 2.36. Fix the crosstalk and erect the perpendicular. Then cut it to 2.36 meter. Isn't it? This is the second point. Similarly, move this to the third point, move this to the fourth point, and the last point is 0. And join all these points. Now we will get the required curve and continue this. Isn't it? Understood? Got it? This is the simple method of arranging the curve. Now this is another method. This is the another method, ranging the curve, linear method, ranging the curve from the tangent, from the straight, ranging the curve from the tangent. Okay. Now we'll analyze this. Now let us understand this also. Okay. Now strictly speaking, see, this is the progress survey line. Progress survey line. Now our curve starts from this point. This is the progress. This is the straight. Our curve will start from this point. Now therefore, we need to calculate the data. Now here, in the previous case, we have discussed, we have drawn the offset from the long curve, isn't it? In this case, from the tangent. Now first let us understand, now what is this, isn't it? From the tangent, how to do this? Now see, now for example, now in the tangent method, now one is, see in the tangent, it is 0, curve start from this end, this point. Then we are commencing the curve, ranging the curve from this end. Now this is T1, it is T1. Then at a known distance, at a x distance, draw a perpendicular. Now this is the offset. This is the offset, isn't it? This is the offset to the offset from tangent. This is tangent. This is tangent. Tangent. At a distance x from T1. At a distance x. Similarly, x1. Similarly, at a distance x2. Now, for calculated offset, draw another perpendicular. Similarly, for another distance from the center, calculated distance, draw another perpendicular. For calculated offset. Now, this is O x1. This is O x2. This is O x3. Likewise, you calculate it, isn't it? And then let us join this. Now this will give you the required curve. This is the offset from. This is the offset from tangent. Offset from tangent. Okay, understood? Now in the previous case, we are drawing the offset from the long chord. That is from the long chord. Now, whereas in this case, we are drawing the curve from the tangent, offset from the tangent. Again, here we have two methods in this, isn't it? One is, this is the offset. No, this is perpendicular offset. We are calling this as perpendicular offset, isn't it? In another way, now see, locate the center. Locate the center, that is radius, is R. Locate the center R, isn't it? This is one method now that we have finished, completed. Isn't it? The another method, see, now this is the radial, isn't it? In the radial direction, at the same distance for the calculated, now this is the offset. This is OX1. And similarly, range the center, range the center, then now this is the radial offset. This is OX2. And similarly, like now this is OX3. So there are two types of offset. You can see this here. The first offset we have done, these are perpendicular offset. Perpendicular. These are the perpendicular offset. Now this is radial offset. Radial offset. Radial offset. Now this is radial offset, and this is the radial offset. Isn't it? Now there are two ways. There are two ways we can see. We can plot the. We can draw the curve. Isn't it? We can lay the curve of the in the field. Then the one method is perpendicular offset method. That is offset from the perpendicular offset from the tangent. Perpendicular offset from the tangent, and perpendicular radial offset from the tangent. Now this is another method. This is offset from tangent, radial offset, then perpendicular offset. Isn't it? Can you recognize this? No, these are the radial offset, radial direction. The bisection is along the to the center, along the radius. Now this is the radial. These are the radial offset. From here to here it is radial offset. This is radial offset, and this is the radial offset from here to here. And similarly, in another method, now this is perpendicular offset. Now there are two types. There are two ways. But from here, 0, T1 to X1, then T1 to X2, then T1 to X3. The distance, isn't it? Now this is out. Now see, again, let us solve the triangle. Only by solving the triangle, now we can calculate, we can do it, isn't it? Again, considering that is T1D. Now this T1D, consider this triangle. Now this is perpendicular here. Now this is the radius are known. We know this. And this is the, what is this? What is this? Offset. It is the radial offset from tangent. Radial offset from tangent, isn't it? This is the radial offset from tangent. This is the radial offset from tangent. It is OX1. O is the offset. X is at a distance, and the first one, X1, isn't it? Similarly, offset, radial offset along the in the radial direction. Now see, consider this triangle. Consider this triangle. Considering this triangle. Consider this triangle. Now this is R known, isn't it? Now this is, it is how much? R plus. Now this is OD is equal to O to D. What is the distance? O to D. O to D is the, from here to here, it is R radius, no? radius of the curve. Therefore, O to D is equal to O to D is equal to what? O to D is radius plus OX, radius plus OX, and this is R, radius of the curve, and this is X, isn't it? Right now, apply the Pythagoras theorem to this triangle and substitute these values, isn't it? That is OD from here to here. You see, you can see this R plus OX square, isn't it? Then this is T1D is equal to X square, and then T1O is equal to R square. It is a simple equation, no? You just transfer this, isn't it? You simply if you transfer this, now we will get this. No, it is the equation we can calculate the X, OX, ordinate and distance X. You substitute for X, isn't it? See, now here X is the only variable, R is fixed, isn't it? Radius of the curve is fixed for the particular curve. Then, like you can solve this. You substitute the values for X, various values from year to year. It is 20 meter, 10 meter, 15 meter, whatever. Substitute it, then definitely we can calculate the OX1, OX, X is the only variable, isn't it? X is the variable, then you will get the more value that is offset. Now, isn't it? And similarly, now this is the radial offset, another one is perpendicular offset, isn't it? Now here, now let us consider the triangle. See, now this is some modifications are made here. Now here, in the radial, in the perpendicular offset, these are the perpendicular offsets. Now here, this triangle is modified a little bit, isn't it? Now this is considered as this location is E, and the corresponding location on the curve is E1, and this is E2. Here, isn't it? Parallel to this is done here. Now this is from here to it is OX1, ordinate, perpendicular ordinate, offset from tangent. Now this is E1 is equal to T1 E1 here, T1 E2. Now this ordinate, this OX is equal to OX. Now let us solve this triangle, that is O, E1, E2. Let us solve this triangle. If we solve this triangle, our problem is solved. Now from here to here it is X, X1. From here to here, E1 is X. E1 is X. And what is this distance? Now from here to here it is, this is R, isn't it? Therefore, this is how much? From T1 E2, sorry, OE2 is equal to how much? OE2 is equal to OE2 is equal to what? R minus OX1, isn't it? R minus OX1. Then our problem is solved. Now this is R. From here to here it is R, radius. From here to here it is X. And from here to here it is R minus OX, isn't it? Now apply the Pythagoras theorem to this triangle. Now we will get this, isn't it? OX can be calculated. Here also again, only X is the variable, isn't it? You apply for X from 0, from here T1, 15 meter, 30 meter, 45 meter, any intervals. Now we can calculate this, isn't it? Now after doing this, so one example, that is one problem you take it. For example, can you see this? Can you see this? Just substitute the values for that, isn't it? We are going to get now one example. Offset at 15 meter interval, the radius of the curve is 360 meter. Substitute this value for the equation. We are going to get the ordinates, isn't it? We are going to get the ordinates. Now for this, yes, just now draw that is intersection, that is straight line. Now from the T1, mark the distance, that is the first stop distance, isn't it? Now this is radial. Radial means you have to direct in the radial direction. 15 meter, bisect this and cut it from here to here, isn't it? Right? And similarly, go to 30 meter, then bisect this. Now this is the perpendicular offset. Now this is the second one, and this is the second one, isn't it? Now here, you mark, you go to 15 meters, From here to here, measure along the tangent 30 meter, 15 meter, then draw perpendicular offset and cut it to 0.31. And similarly, 30 meter, then draw perpendicular. Now from there, isn't it? Cut it to 1.25 meter, like you continue this and finally join all these points. Now we'll get the required curve. Isn't it? Got it? Now anything, any queries you can ask, isn't it? Or else, if you don't have time, now we'll discuss. You can ask me in the next class, isn't it? Next again we are meeting on Wednesday, isn't it? Next Wednesday. Okay? Thank you very much. Thank you so much for everybody. Thank you a lot.